So let's talk about projectile movement components, strangely enough, so we can make our projectiles move. By the end of the video, you will be in a situation something like this, where we can fire beach ball-sized projectiles at our other tanks, which will be a lot of fun. Okay, see you in there. Oh, boom, off he goes. So spawning massive projectiles at the end of our barrel is fun and all that, but it's not exactly making a great tank game. So let's make these projectiles move. I'm going to introduce you to something called a projectile movement component. Now we're going to start by using that here on the projectile blueprint, but I'll very quickly take it off and we'll do it in C++ because this is a C++ course mainly, but either way is valid. So let me just look at it with you first. Projectile movement, that's the name of a component. Got a lot of stuff on it. In fact, it's got a bewildering amount of settings and levers that you can pull, which is one of the reasons I'm going to be using it from code instead of from here. But the projectile can bounce and it can home on things and it can have its movement constrained to certain planes, and it can be made to rotate following the velocity. So imagine it was an old school bomb, then it would always kind of have its fins facing behind it. It's pretty comprehensive component, this actually. So we could add it like this, but I'm going not to. We're going to remove it from the blueprint, and we're going to add it in the same way that if you remember on the tank blueprint, we added the aiming component as an inherited component, and we did that from code like this. Let's just open Visual Studio. We added created a default sub-object on the tank, if you remember. Let's see where that happens. It's in the constructor of the tank where we say create default sub-object aiming component. Where is it? There it is, that line there, 17 in my code on the tank CPP. And that will add that code, that component to the blueprint without you having to do anything about it, because the tank is inherited from the tank blueprint is inherited from the tank C++. This guy gets inherited, this aiming component. It's in there whether you like it or not, and you can't change anything about it. You hide all that complexity. Well, let's do the same thing with the projectile. Let's add this projectile in code. Now, just before I put you into the challenge to do that, just as a little bit of a hint, we're going to go to I'm going to go to the class viewer, and I'm going to, sorry Mac users, you can't see all classes, but you can look on my screen. Projectile movement component, the name of the class is going to be projectile movement component. That's the thing we're going to be after. So let's give you this as a challenge then. What we want to do is we want you to add a default sub-object. Add the projectile movement component in C++. When it's done, set the beAutoActivate property to false immediately after you've done it in the constructor. And then refer to how we did things in the tank to do this. It's basically the same with a different class name. So go ahead, pause the video and see if you can make sure that we have a movement component on the projectile as an inherited component by default. I know you can do it. For those of you who are beginners, then put the extra effort in, and for those advanced people, well done. I know it's probably simple for you. Okie dokie, so let's do this thing. Firstly, we need to start on the projectile. We need to have some sort of variable to store this. Now, this is a private variable. It's just a helper property. So in the private section, I'm going to say a projectile movement component pointer, and I'm just going to call it projectile movement, and we're going to initialize it to the null pointer to give it a known value. So there you go, we have our variable called projectile movement. All right, now I'm going to go to the tank and borrow this create default sub-object because it's a lot to type, and we're going to go and do this over in the projectiles constructor. So I'm going to say that looking at the tank aiming component equals is how we did it over there. So here we're going to say projectile movement equals create default sub-object of type. Now we had the type before, it's a projectile movement component. And now it's going to want a name. So we're going to call it fname. And then projectile movement. Simples, hopefully. So that should have said it. I also said that once we'd got this guy, we wanted to set a property on it called AutoActivate, which is beAutoActivate. Now it's a pointer, so we're going to need to use the arrow operator. So projectile movement beAutoActivate equals false. And what this means is it doesn't start flying off until we actually fire it. So what we're going to do is compile up our code and make sure we understand what's going on. So we're adding a new default sub-object to the projectile blueprint. That is going to be the projectile movement component. We don't want the projectile to go flying off at the moment that it is constructed. We only want the projectile to go flying off when we fire. So typically that may be at the same time. You may construct it and send it flying off at the same time, but we want to make sure for our testing now that we just have the thing instantiate and not move. So let's just try. Let's compile up this projectile blueprint. It failed for me. Let's try again. Maybe because we changed the default stop property of the projectile blueprint, it didn't like that happening on the fly. So let's just give the editor a chance to recover. And actually it is there now. Look, projectile movement inherited. That's cool. I'll make sure it can compile. Let's play the game. And nothing's changed because all we've done is added this projectile movement component. We haven't actually done anything with it yet. But that does mean that over here in the C++ code, we have this projectile movement thing. And we're ready to write our launch method or launch projectile. So let's have a method called void a projectile, the class we're in, launch projectile, and we're going to launch it at some speed. Now before I do anything else, let me declare this over in the header file. That's a public method in this case, without the class name. Perfect. And it's the tank that's going to launch the projectile, so why don't we just go ahead and call it from the tank straight away. So the tank is going to spawn a projectile in the correct location, and then it's going to go ahead and launch the projectile. But it needs to have a concept of the projectile in order to do that. So we actually spawn the projectile right here, and this spawning actor actually returns us a projectile. So we're going to just capture that value, auto projectile equals, and then this actually gives us a projectile to work with. It's a local variable at this stage, which is absolutely fine. Now we can work on that projectile. We can say projectile. Then we can call a method on it, which is launch projectile. Finally, we need to pass in a speed. Well, we have a speed in the header file. Remember, it was a launch speed, and it was 4,000 by default. So let's pass in this launch speed, and there we go. Now, let's try this, and then I'm going to briefly talk to you about the difference between edit anywhere and edit defaults only. But firstly, let's try it. Let's make sure that this actually works. So as a recap, while it compiles, we're sending launch projectile through to the projectile code, which is doing nothing yet, but we can soon sort that out. Let me move my logs in here from the tank firing. This log here, let's just move it so there's nothing in the tank CPP into the projectile, and just say, oops, didn't quite cut that right. Let's try cutting again, pasting it in here. Tank fires, or projectile fires now. At, and then let's put in the speed. Great, so let's just recompile. And then we're going to have a log inside the actual projectile's launch projectile method telling us the time that we fired and also the speed. So we should be seeing 4,000 coming through, unless, of course, in the tank blueprint you've overridden that value here in the launch speed, then you'll get a different speed coming through. Let's take a look. Ah, here you go. Tank fires at 4,000. If we go to the tank blueprint and turn it to, say, 3999 and compile and play, you can see that that value from the inspector or the details panel is overriding. Great. So that is happening. We are nearly there, but the projectiles aren't actually moving. So we've just got a tiny bit more work to do to make those guys actually fire. Let's see what's going on in our execution path. So from the tank CPP, we launch a projectile at a given launch speed. We know that value is coming through because of the log that we've just done. We get to the projectile CPP, and of course we are not yet launching. So the way that we do this is we go and grab the projectile movement component that we've got there. It's a pointer, remember. The method we're looking for is set velocity in local space. And then we can just get the forward vector of the projectile itself. And remember that when we spawned the projectile in the first place inside the tank C++, we did it with a rotation of the same as the barrel. So the projectile should be facing forward in the same direction as the barrel. So this forward vector will be hopefully the barrel's forward vector. Once we've got that vector, it's just a unit vector, so we need to multiply by this speed, and that will give us that initial launch velocity. The second thing we're going to need to do is actually activate the projectile movement component. Oh, I'm going to copy it. No good trying to type this morning by the looks of it. And then we're going to say activate, which is a method. so that the deactivation that we did on the start here is then countered by the fact we've called an activate. Now this is a method notice, and setting auto activate is false is a property. It's just so this is saying that when we construct it, don't auto activate, but as soon as we launch, set the velocity, then go ahead and activate so the thing actually fires. Let's have a go, see if it works. And if it does, I think that'll be enough for this video. Launching beach ball sized projectiles is a pretty good outcome for one video. So let's just see that it works. It compiled, let's try. Oh, look at that. Cool. Beach balls are away. Boom. Awesome. Fantastic. So I am now going to leave on the screen the main code, which is that bit there. For the rest of the code, remember, you can always go to GitHub. I'll just quickly show you this. If you go to my GitHub profile, or if you wish, you can go directly to the Unreal course repository there. You go to Battle Tank, you click on commit, and you can see every single video in the course. This one's not quite there yet, but imagine it was. You click on that, and then you'd be able to see all the code that's been added in this video. So useful tip for you. I'll put this in the resources of the lecture for you, and I will see you soon. In fact, I'll put this in the resources of the lecture. So see you soon.